Resistors in parallel. Consider a circuit that has a supply voltage of 48 volts connected to two resistors in parallel. R1, 8 ohms, and R2, 4 ohms. We may wish to find out what is the total current supplied by the voltage supply and what are the individual currents inside of each flowing through each resistor. So in other words, we may need to want to find the I supply, I R1 and I R2. Okay? Yes. So we have a supply of 48 volts, 8 ohm resistor in parallel with a 4 ohm resistor. Now before we do some calculations, let's look at some characteristics of this circuit. In a series circuit, in a parallel circuit, the current is divided in proportion to the resistors, with the larger current flowing through the smaller resistor, and the smaller current flowing through the larger resistor. So anytime you do a calculation, you can always double check that for it to make sense, the larger current must flow through the smaller resistor, and the smaller current will flow through the larger resistor. Now, the first step in doing a calculation on the resistors in parallel is to find the total resistance of the parallel configuration. Okay? Once we can calculate the total resistance, then we can use Ohm's law to calculate the total current. So the total current we can write on here, we can the symbol for the current will be the supply current, will be the total current. Okay? Right. So the question is, how do we calculate the value of two resistors in parallel? Well, the formula for two resistors in parallel is simply R total is equal to the R1 multiplied by the R2 divided by R1 plus R2. And you can put it in brackets to make sure that you're adding R1 plus R2. You're multiplying R1 by R2 and divided by R1 plus R2. So you have what we call the product of the two resistors divided by the sum of the two resistors. Okay, so that's the formula for two resistors in parallel. We're going to see that if we have more than two resistors in parallel, this formula cannot work, and there's another formula that will work for any number of resistors in parallel, including two. But for now, we're going to concentrate on two resistors in parallel. So let's do the calculation for this circuit here. So we have that R total is equals to R1 by R2 divided by R1 plus R2. That equals 8 ohms by 4 ohms divided by 8 ohms plus 4 ohms. And that comes out to 32 ohms divided by 12 ohms, and you get 32 divided by 12. I have to go to the calculator. 32 divided by 12, and it gives 2.6666 recurring. 2.666 recurring, and we can write that to 3 significant figures equals 2.67 ohms. Okay, so that is the total resistance of the two resistors in parallel. Right. Having done that, we can now use Ohm's law to calculate the total current. Now we can actually redraw this circuit. We can redraw this circuit as a simplified circuit, which would be, we still have 48 volts, and we can redraw this circuit as one resistor of value, so that's RT, of value 2.67 ohms. So what is I supply? I supply, so the I supply will be simply 48 volts divided by 2.67 ohms. And that would be equal to that. 48 divided by 2.67. Divided by 2.67, and that comes out to 17.97. If we write that down to 3 significant figures, that comes out to 18.0 amps. Okay, that comes 18.0 amps. All right. Now, I'm running out of space here on the board, but we can write here that we have IS is 18 amperes. Now, what is going to happen is that a portion of the 80 amperes will flow through here, and the other portion flows through here. But we can do a quick calculation just to show you. It's a parallel circuit, so we have 48 volts applied across 8 ohms here, the same 48 volts across 4 ohms here. So we can calculate the voltage. Let's do it over here and make some space here. Right? IR1 is equals to 48 volts divided by 8 ohms. So 48 divided by 8, you get 6 amps. Right? So the current through here is 6 amps. And what is the current flowing through the 4 ohm resistor? It is simply this IR2 is equals to 48 volts divided by 4 ohms, which is equals to 12 amperes. So the current flowing through R2 is 12 amperes. So if you check you have 6 amperes flowing through R1 and 12 amperes flowing through R2, and that adds up. 6 plus 12 gives 18. The supply current is 18, and 6 flows through R1, 12 flows through R2, so the total is 12 plus 6 gives 18. And so a video coming up, we are going to discuss, there's a law called Kirchhoff's current law that actually formalizes this relationship of the current flowing into a node with the current flowing out. But that will be dealt with in another video. So to recap, for 2 resistors in parallel, another video we'll have to look at the formula for more than 2 resistors. But for 2 resistors in parallel, the formula for the total resistance is R1 by R2 divided by R1 plus R2. Okay, so I will produce another video that shows you how to calculate the total resistance in parallel for more than 2 resistors.